Welcome to another lesson on Pure 2, Chapter 11, Integration. Now, this lesson will be looking into integration with trig identities. Another difficult question following from the last one, which is about reverse chain rule. So you must grasp reverse chain rule before moving on to 11.3 trig identities, which is this lesson, because reverse chain rule we need it for today's lesson as well. So again, it's going to be quite a difficult lesson because just the amount of content, not amount of content, but the level of understanding we need in here. So if need be, try to go through it again and again, unless you understand step by step what we're trying to do in here. Now, quick recap on chain rule. What's reverse chain rule? Not chain rule, reverse chain rule. Reverse chain rule is we are letting y to be an answer that when we differentiate will give us what the question asks for. So for example, in here, if I want to integrate 1 over 3x plus 2, I will be thinking about what differentiate give me 1 over. That will be ln. So then I will go to, that's my guess of the answer. That I will try to differentiate ln using chain rule. So 1 over 3x plus 2 times 3. Then that's how I verify my guess. And my guess is not far off because my algebra, 1 over 3x plus 2 is right there. But what's different is that we have a 3 on top instead of 1. So we just have to multiply by a third of our guessed answer, which is a third of ln 3x plus 2. And don't forget our child plus c. So there's reverse chain rule. Today's lesson, integration with trig identities. Now, before we do that, let's have a look in here. Right, so some expressions such as sine squared x and sine x cos x can't be integrated directly, but we can use one of our trig identities to replace it with expression we can easily integrate. So to do that, we are going to just recall some identities. Okay, so recall these are some useful identities we can use. So recall. Okay, recall. So these are some useful identities we can use. First of all, the first one is that we have got 1 plus 10 squared a equals sec squared a. Now, I didn't use x in here. The reason being is because I don't want to confuse you with the x and later 2x and 3, etc. So use a. One of them would be 1 plus cot squared a equals cosec squared a. I'll give you a bit of spoiler, lucky you. Now, remember, you having formula booklet. If you don't have it, make sure you take it out now because we're going to use the formula booklet now. So go to page 6 and page 7 again, a spoiler, okay? Now, let's say we want to integrate 10 squared, okay? Now, if you look at 10 squared, we've got nothing about 10 squared. We've got 10x in here, but we know in integration, if the power is not the same, we can't use this directly. It's not like differentiation, we can use chain rule, but we can't. So we got 10, but we don't have 10 squared. So what do I do if I need to integrate 10 squared? Well, good thing is we've got sec squared, which is connected through the identity. So in this 1 plus 10 squared equals sec squared, if I have to differentiate 10 squared, then I can use 10 squared, make 10 squared subject, and move the 1 over. Then instead of integrating 10 squared, I'm integrating sec squared a minus 1, which sec squared a is on the formula booklet. And hence, we're using the identities in here. Okay, right. So 1 plus 10 cot squared equals cosec squared. Same thing in there. Another one we're going to use for is going to be cos 2a. Actually, sine 2a first. Sine 2a equals 2 sine a cos a. We also have cos 2a equals 1 minus 2 sine squared a, or equals to 2 cos squared a minus 1. Now, these two are going to be very, very useful. Let's have a look. So, example in here, integrate sine squared x. Now, if you remember sine x about the clock, sine, cos, negative sine, negative cos, these are just power of 1. Sine to the power of 1x, cos to the power of 1x. Nothing to do with square. You can't apply the square into the sine x, cos x clock. What I'm trying to say in here is, sine, cos, negative cos. We know differentiating that way, integration the other way. But it doesn't work if you put a square in there. It doesn't work like that. It doesn't work like that. So please do not do that. So these sine, cos, clock only works for sine x and cos x. but not anything with power. So what do? We need something to help us, okay? We need someone to help us. The help is here, which is about identities. Now, have a look on the right side, okay? Think about which one you can use, okay? We're going to use this list of identities. Pause the video, think about which one we can use. The only thing about sine squared we can use is this one. Cos 2a equals 1 minus sine 2 sine squared a. So I'm going to write in here, okay, because cos 2a equals 1 minus 2 sine squared a. Now, if you compare the question, you can see the question is asking for integral of sine squared at x. So sine squared should be the subject. Okay, now do write a little step on what my thinking process is. Okay, I'll start again. The question wants to integrate sine squared. I realize I need some help because the formula booklet does not give me sine squared, and also the sine x cos x clock does not do squares. So I need to use identities. The identities that relate to sine squared is this one. One question, since we're on the subject of identities, so why don't you use sine squared a plus cos squared a equals 1? The reason is if you use this one, then you rather than dealing with sine squared, you are dealing with another issue which is quite similar, which is the cos squared instead. So this identity doesn't do much in here in this case. Therefore, we're going to use a cos 2a equals 1 minus 2 sine squared a. That's 1. 2. Next step. Since the question is asking for sine squared x, we want to make sine squared a the subject. Okay, so that's what we're going to do. Okay, make sine squared a subject. So it'll be 2 sine squared a equals 1 minus cos 2a. So I'm trying to make sine squared a the subject. That's how we use the identities. Okay, use identities based on what the question asks. We want to make that the subject. So then I'll divide the 2 over. Now, when I do divide 2 over, I've got a little trick in here. I'm not going to write everything over 2. I'm going to write 1 over 2 minus a half cos 2a. Because when I integrate, having it separately is better than having it out of a whole fraction. Right? So a half minus a half cos 2a. So therefore, okay, so once I've made sine squared a subject, therefore I can replace. So the question was sine squared x, integral of sine squared x. Now I can rewrite as integral of, instead of sine squared x, I can rewrite as a half minus a half cos, not 2a, 2x, it's 2x, okay, dx. That's how we can use the doubling of formula identities, okay? Now, if you remember last lesson, what we do is, first of all, when we see an integral, when we have to integrate something with a minus in there, we can separate them. So it'll be a half dx minus, I can also take a half as a coefficient, cos 2x dx, right? A half dx, integral half dx, we know it's easy because that's a half x. It's like integrating 5, it's 5x. The next part, now minus a half, I'm not going to do anything with that. Minus a half is minus a half. Integral of cos 2x. How do we do that? Is that not the same as sine squared, something similar? No, it's not. Because without a power, we can use reverse chain rule. So remember I said the importance of reverse chain rule, understand reverse chain rule before going to this lesson. And that's the reason why, okay? So so in here, well, what differentiate it because, well, this reverse chain rule, RCR, reverse chain rule. So we can let y to be sine 2x because differentiating sine will give me cos. So dy by dx differentiate that will be differentiate sine 2x is cos 2x, differentiate 2x is 2. So chain rule 2 cos 2x. Therefore, the integral of cos 2x is a half sine 2x. A half because there was no, you're comparing a 1 with a 2. The shortcut to integrate cos 2x is, remember with differentiation, you're going to do 2 sine 2x. But integration, instead of multiplying by 2 in the front, you divide the 2. Okay, so it'll be a half sine 2x. So that one will be here. So times a half sine 2x. I'm going to highlight a different color so to show you this is where this came from. Okay. And then, of course, we're not going to forget for a child, the plus c. We're not going to leave the child in the street and forget about them because we are so full on with our ice cream. And when we get home, oh, where's the child? But who cares? We've got ice cream, haven't we? So ice cream or child, we choose one. Of course, ice cream, if I had to choose. A half times a half is a quarter sine 2x. Plus 2. Okay. So, so recap what I've done here. First of all, I need to choose the right. I need to look at the formula booklet. I realize formula booklet can't do anything. Okay, useless. Then I have to record second help, which is identities. I'll record the identity cos 2a equals 1 minus 2 sine squared a. Make sine squared a subject, and then replace it to the question. Replace it from the question, and then integrate separately. When I need to integrate with reverse chain rule, I use reverse chain rule. Okay, next one. Okay, integral of sine 3x cos 3x. So again, look at this list. Okay, maybe you can tell me which identity that might be useful in here. Okay, maybe you can tell me which identity might be useful in here. So pause the video, think about it. The answer that will be useful is, you see, sine A cos A, maybe something to do with this one, sine 2A, because sine A cos A. So because sine 2A equals 2 sine A cos A, so what I'm doing here is, I see this sine A cos A, very similar to the question. So I want to make sine A cos A the subject. Well, why sine A cos A? Because the question has sine A cos A in there, and hence the whole thing. So we divide by 2 over. I'm going to write a half sine 2A equals sine A cos A. Okay, just like burger without pickles and sausage roll with ketchup, I'm going to write the subject on left hand side. That's my usual thing to do. Okay, half sine 2a. So therefore, we can now replace it with, therefore, the integral of sine 3x cos 3x dx equals 2. Now, compare it carefully. Your a is 3x. Therefore, the right-hand side is the integral of a half sine 2a 2 times 3x dx. Now, one thing to note, we have not integrated. We're just replacing the function to integrate. Okay, we have not done any integration. We're just replacing it to something we can integrate. Okay, it's like making, instead of flour, you are making some pastry out of it. We are just changing the format out of it. Okay, so integral of sine 3x cos 3x dx. We have not done integration. Now I'm going to do some simplifying in here. I'm going to take the half outside because the half is a coefficient. Integral of sine 6x dx. We know how we can integrate sine 6x, don't we? Because a half sine, so integrate sine, so sine, cos, negative cos. Integrate sine is negative cos. So it'll be negative cos 6x. But because it's a 6 inside, we have to divide a 6. Okay, divide a 6. Divide 6, that'll be 1/6. So it'll be negative 1/6 cos 6x. Now, normally, in differentiation, you do a 6 cos 6x, but integration, you do a 1/6. Okay, so it's the opposite. So in here, we have a plus c, of course, when we integrate, that'll be minus 112 cos 6x plus c, and that's the answer. Okay, there's a short one, so I will verify for you. So let's say we'll verify. How do we verify? We differentiate. If we ever differentiate, okay, minus 112 cos 6x, okay, let's differentiate. So minus 1 over 12 has nothing to do with it. Differentiate cos xx. Cos 6x, differentiating cos is sine. Okay, so it'll be sine 6x. And differentiating sine 6x will be 6. That minus or half sine 6x. But how is that the same as the question? The question is sine 3x cos 3x, because sine 6x is the same as 2 sine A cos A, which is same as minus, oh wait, hang on, differentiating cos is negative sign, so negative sign. So plus, no wonder why it's there. Negative in there. Positive sine 3x cos 3x, which is same as the question. And that's how we verify we can differentiate. Right, next one. Okay. Again, think about what would you do first. Now I'm putting these identities in here doesn't mean we have to use it straight away, but what I want you to do is think about, okay, brainstorm, what would you do first? Okay, think of an answer. You see this question to integrate, what would you do first? Now here's what I would do first. I see a bracket with square more than one term. I would just expand the bracket. expand the bracket. So integral of sec x plus 10x squared, I'll expand this double bracket. So which is integral of sec squared x plus 2 sec x 10x plus 10 squared x. That's double bracket, right? Expand double bracket. Now, I still see students up to year 11, up to year 12, year 13, when they expand double bracket, they just apply the 2 into each of them, which is not the case. You have to do this double bracket, okay? Do not afford this silly mistakes. You can't afford to do so in A-level because it will cost you dearly so many marks. Yeah, and this is where cry doesn't work because you can't cry to marker and the marker won't let you in. They don't care about you. Next one. So now, next, we can integrate one by one, okay? To integrate one by one, right, I'm going to do it separately, okay? So I'm going to write out, this step is up to, is really up to you. Middle one, I'm going to put a 2. Third one is just integral, hence, but I'm just separating them. Okay, this one. Right, now, one by one, sec squared x. It's time to use our formula booklet. Formula booklet is here, sec squared x, we got it. Integrate sec squared, or in here, is 10kx, 1 over k 10kx, but it's sec squared x, so it's just sec squared 1x, so the k value is 1, so it'll be 10x, lovely. So it's just 1 over x. Sorry, 10 over x, 10x, sorry, 10x. So this one is just 10x. Okay, now I'm going to just write in here, I'm just going to write in here in purple because it's just in draft. How do I get this answer? Well, actually, use black for this one. 10x. I'll get this because this is formula booklet, FB, formula booklet, not Facebook, formula booklet. Sec x 10x. Let's look at the formula booklet again. Sec x 10x. Do we have anything about sec x 10x in here? No. What about the top in here? Yes, we do. Okay. Remember, we can also use differentiation chapter, work it backwards. Differentiating sec x is sec x 10x. That means if I work it backwards, integrating sec x 10x, I'll give sec x. So this one will be just sec x. So sec x. Again, from formula booklet. Last one, 10 squared. If you remember what I said earlier ago about a spoiler, you would know there's nothing on the formula booklet that gives you 10 squared. That's 10, sec squared. That's sec squared 10, 10. Again, there's no 10 squared. This is where we have used the identities. So let's use identities. So identities, what I've used is the first one. 1 plus 10 squared equals sec squared A. So we need to use identity. So we're going to use identity in here. We're going to use identities. Identity, 1 plus 10 squared A equals sec squared A. We want 10 squared the subject, so I make 10 squared A the subject. Okay, so what I can write the next line. Okay, so after all the draft, or after all the brainstorming, okay, check it one by one, I can rewrite the whole line. The integral of sec squared x is 10x plus 2. This one goes to sec x, sec x. The next one, I've not done any integration, so I keep the integral sign, but rewrite 10 squared x as sec squared x minus 1 dx. Now that's why it's powerful that you can you write each term separately. So you can integrate one by one. Some expression could be integrated in one go, but some can't. The first two could be integrated quite easily with the formula booklet, but third one we have to do an extra step, which is to rewrite it using identities. Okay, now sec squared x, again using formula booklet, sec squared is 10x. Therefore, we can write 10x plus 2 sec x plus the integral of sec squared x is 10x. Again, how do you get that? From formula booklet. Okay, integrate 1 x plus c. We can do some simple simplify. 10x, 2 10x. So 2 sec x minus x plus c. And that's the final answer. Okay, right. Now, this practice question is actually quite difficult. So if you would like to, you can pause the video, have a go at some easier question from the homework first, okay, and come back to this question, okay, when you're a bit more ready. This practice actually, it's not as easy as you think. But if you would like to go on head on the challenge, go into deep end, and you want to go through this, yes, you can. You can pause the video and have a go at this question, right? Whenever you're ready to play the answer, get the answer, you can press play. Now, if you're struggling with the how to start the question, okay, how to start, what you can do is have a look, okay, sine squared. So I need to definitely use this sine squared, which is here. So sine squared is this one here. I'm going to use this, okay, 1 minus 2 sine squared a. So I'm going to say cos, right, cos 2a equals 1 minus 2 sine squared a. Then I can do cos, I make sine squared a subject. If you don't know how to start, you should start from this and make sine squared a the subject, okay? And then you can pause the video and carry on. I'm just continuing in here. If I rearrange it, you should get a half minus a half cos 2a. So therefore, the integral of pi over 3, pi over 6 of sine squared 3x equals to the integral of pi over 6, pi over 3, a half minus a half cos 2a. My a is 3x, so it'll be cos 6x dx. Okay. Next, the integrate a half is a half x. And then minus a half, oh, actually, integral cos 6x, so that's now I need to calculate the range. Yeah. So next, then I need to, before I need to substitute, I need to integrate this part. So it's a half x minus a half times, to integrate cos 6x, integrate cos will give you sine 6x. Integrating 6x will be 1/6. So 1/6 sine 6x, pi over 6, and pi over 3. Okay, simplify it down, you will get a half x minus 1/12 sine 6x, pi over 6 to pi over 3. You sub it in, and you should get pi over 12. Okay, 1 by 1. So you sub it in 1 by 1. You should get pi over 12, and that will be your final answer. And that will be the end of this lesson, I believe. Yep. Now, this lesson is going to be very, very important because a lot of the trig expression that you integrate, you will have to rely on the identities. So make sure you do a lot of questions on this. Make sure you get familiar, get comfortable with this chapter before moving forward. Just like the chain rule, without knowing reverse chain rule, you'll struggle with this, and etc. Okay, so, and that's the end of lesson.